everyone, this is the video for the lesson 3.1.1 review and preview problems. 3-5 says for each of the following expressions, find at least 3 equivalent expressions. Which do you consider to be the simplest? Looking at A, right away I see we have 2x minus 3 squared plus 5. The squared tells me that there's actually 2 of the 2x minus 3, so let's rewrite it. So just focusing on this part, we can actually multiply these together by doing, we could distribute or we could use the box method. So I'll make a box. All right, so 2x times 2x is 4x squared, minus 6x, and plus 9. So when I write this all out, we have 4x squared minus 6x plus 9, and don't forget we have that plus 5 here as well. We can combine like terms, so we've got 4x squared minus 6x is minus 12x, and 9 plus 5 is 14. And there we go. For B, we've got 3x squared, 3 times x squared times y divided by x to the 3rd power all to the 4th power. So the way I like to think about this is we can like take everything to the 4th power, but we have to use certain rules to do that. So here, 3 would be to the 4th power. With exponents, we're going to multiply them. So this would be x to the 8th power, and then y to the 4th power, all over x, and then 4 times 3 is 12. Okay. To finish simplifying, and I can show you guys in the calculator here too, we've got, so we can take 3 to the 4th power like this in our calculator. So we've got 81. And then we've got x to the 8th power, y to the 4th power, all over x to the 12th power. And we can't forget here, this would actually be 8 minus 12, which is a negative 4. Okay, so we are going to have 81 times y to the 4th. And because, like, if we were to write this out, like 8 times 8, or x times x times x, all of the times, and then underneath, and we start canceling them out, what we're going to have left is just 4 of them under here. Okay. All right. The next one wants us to match each expression on the left with its equivalent expression on the right, assuming that all variables represent positive values, and be sure to justify. So if we start just even with let's just start with A. The square root of 4 here, that would be 2. This would become x and then y squared. So that one goes with letter, it looks like, or number 3. Okay. Here, this becomes 4 times 2 times x squared times y. So we can take the square root of that 4, so that would be 2, and we'll leave the x out here. And then we are just left with 2y, so that one goes with number 4. Letter C, we've got the square root of 4, which is 2, and then we've got our x and then the y. So that goes with number 1. The square root of 16 is 4, and then the square root of y squared would be y, and we've just got the x there. So that goes with number 5. And then the last one, we've got, we can make this 4 times 2 times x times y squared. So this would be 2, and then y, and then we've got the 2x. So that goes with number 2. Okay, 3-7 says Bonnie and Dylan were both working on simplifying the expression 2 times x to the 5th power times y to the 4th power divided by 8 times x times y cubed all to the 3rd power. Each of their steps are shown below. So let's look here at Bonnie and Dylan. All right, so each of them are convinced that they have simplified correctly. So let's take a look and see if one is correct, both are correct, none. Let's go for it, okay? So I'm going to solve it like how Bonnie did, and then I'll show you what it is that Dylan did. If we look at Bonnie, so everybody keep in mind, we're starting with that original up there where it's the 2x to the 5th, y to the 4th, the third power. So what Bonnie did was she actually solved the problem like I did in the problem up here for letter B by using that power like and bringing that through right away. So this became 2 to the 3rd power, x to the 15th power, and y to the 12th power, all over 8 to the 3rd power, x to the 3rd power, and y to the 9th power. Okay, so 2 to the 3rd power, that would be 8. And then we've got x to the 15th, y to the 12th, and then 8 to the 3rd power is 512, x to the 3rd power, y to the 9th power. Okay, so that's where Bonnie stopped, was right there. Technically, Bonnie is correct. I think we maybe could simplify a little bit more, but still correct, right? They've started the problem correctly. That's what we're talking about. So to me, it looks like she did start the problem correctly. So now let's take a look at Dylan. Okay, so remember, we're starting from the beginning. We've got 2x to the 5th power, y to the 4th power, all over 8xy cubed, and that's all to the 3rd power. So something I'm noticing with Dylan's step here is that 3rd power is still there, so I don't think he's done anything with that. So I think what Dylan did was started simplifying on the inside first. So we took 2 over 8, which would be 1 over 4. Then it looks like we took x to the 5th over x to the 1st power, which is subtraction. So that would be x to the 4th power, because you subtract the powers. And then y to the 4th over y to the 3rd becomes just the y. And that's still all to the 3rd power. That's exactly what Dylan has here, right? There's always that imaginary 1. That's exactly what Dylan has. So he also started the problem correctly. So I'm going to write they are both correct. Okay. All right. 3-10. Okay, so we've got a little bit of a geometry review here. It says if the pattern continues, so we're looking at these two triangles here. And it says if the pattern continues, what do you think the next two would be? So let's look at the first one. We've got 1, and then our other length here is 3, and then 2. Okay, and I can see that they're also both 30, 60, 90 triangles. So you kind of have to think back to geometry a little bit and think about like, what was that rule again? And then they want us to come up with the next 2 lengths. So one thing that we should be seeing here is if we've got 2 more triangles, I'm just going to write down here even though this is technically the answer for B. Okay, we got our 90. So if we've got 1, 2, 3, I'm going to assume this is going to be 4 and this is going to be 5. Notice then that this side here would be 4 root 3, and this one would be 5 root 3 to continue that pattern. And then what happens here is this is double of those lengths, right? So this length here is going to be 8, and this one is going to be 10. Okay? And to answer part B, to explain it, the long leg is n to the root 3 units long, and the hypotenuse is 2n units long. Okay, so I'll give you a second to write that. Okay, almost done here. We just got this last question, 3-11. So it looks like we're going to be thinking back to some of our sequences. So it says consider the sequence 3, 9. So it says assume the sequence is arithmetic. With the first term, with t of 1 as the first term, find the next 4 terms in the sequence and then write the equation. Okay. Well, we know we've got 3 and then 9. If it's arithmetic, we're going to be adding. So it looks like that's plus 6. Okay. So you can always even just do this. 9 plus 6, plus 6, plus 6, and plus 6 if you need to. So the next 4 terms would be 15, 21, 27, and 33. Okay. So let's say we've got our formula t of n equals dn plus a sub 0, or t sub 0. Okay. D means what's happening each time, so we're adding 6. And the t of 0 means what happened before then. So we'd actually have to take 3 minus 6, which is minus 3. And there's our formula. Okay. But on this one, what if it's geometric? Okay. So we've got 3, 9, but now we're multiplying what looks like by 3 each time, right? So we've got to do 3, so we've got 9 times 3, times 3, times 3, times 3. So that would be 27, 81, 243, and 729. The formula for this is t of n equals t of 0 times r to the n power. So it's saying, well, what's the 0 term, right? And then what's the common ratio, what's happening each time? So if we were to go backwards, 3 divided by 3, that would be 1 times 3 to the n power. All right, that's all for this video. Watch the next one to see the review preview for 3.1.2. Thanks.